Okay, now we continue with question 1.2. We just did 1.1. Haven't seen that, you can go back and watch the previous videos. Question 1.2 is also pretty simple. It's a simultaneous, you have to solve these simultaneous equations. First thing I want to do is have this equation here in the same form as this one here, because here we have x and y as the powers, and here we have x and y as bases, and that's a bit difficult to solve in this form. So we want to simplify it. How do you simplify it? You know that 27 can be written as 3 to the power 3. And why do you want 3 to the power 3? Show you in a bit. X is equal to 3 to the power x plus y is equal to 3 to the power 3. And by the laws of indices, you know that if a to the power b is equal to d to the power c, then b and c should be equal if a and d are equal, right? Therefore, x plus y should be equal to 3. So we have one equation there. I'll name that equation 2, and this one equation 1. Just do that in black. Do equation 1. And now the simplest way to solve this is by substitution, because elimination is not possible to do in this case because we have x here and an x squared there. Then you can make one of the variables substitute formula. I'll just choose y in this case. So y is equal to 3 minus x. Name this equation 3. How do we solve? Sub equation 3 into 2. Then we have x squared plus 3 minus x all squared is equal to 17. Simplify that. You have x squared plus, expand this as I said before in the previous video, if you have something of the form ax plus b all squared, that is equal to ax all squared plus 2ab x plus b squared. That's the simplest way to expand if you have something of that form. So this is going to be plus 9 minus 6x plus x squared is equal to 17. Simplify further. 2x squared minus 6x plus 9 minus 17 is equal to 0. I separate 17 from both sides of the equation, or you could simply just think of it as moving 17 to the other side and changing the sign. This is equal to 2x squared minus 6x. 9 to 17, 1 plus 7, that's 8. So negative 8 is equal to 0. Now you can see that all of these are multiples of 2, so you can divide by 2 all throughout on both sides of the equation. Simplify this further. Then you have x squared minus 3x minus 4 is equal to 0. And again, you use product and sum. Sum and product. Should always say it in that order so that you remember from left to right, sum product. And in this case, it's pretty easy to see that our two factors are 4 and 1, because if you have 4 minus 4 plus 1, that's minus 3. Minus 4 times 1, that's minus 4. X minus 4, x plus 1 is equal to 0. X is therefore equal to 4. Is equal to negative 1. So that gives us our x values. But remember, you also have to solve for the y values as well. And how do we solve for the y values? You can use equation 3. Substitute both the values of x, these two values here. So let's substitute y is equal to 3 minus, substitute the first one, 4. Y is equal to negative 1. Y is equal to 3 minus -1, y is equal to 4. Those are the two values of y. That was simple. Now we move on to the last question of question 1. Let me just clear up some space. To solve that. If you're looking for the answers to this, you can watch the previous videos. You can go through the previous videos for all of this. Well, it's only one video, but anyways, let's continue. Question is determine without the use of a calculator the value of 1 over root 1 plus root 2 plus 1 over root 2 plus root 3 and so on and so forth up to 1 over root 99 plus root 100. So what you want to do here is think about this question. Let me just write it down before we solve it. This is question 1.3, is it? Yes, 1.3. Let's write it down. We have 1 over root 1 plus root 2, and because they say without use of a calculator, that should hint at something. You obviously cannot solve root of, well, you probably could try and estimate it, but as I say, it's only an estimation, it's not accurate. The value of root 3 or root 2, those are all estimations, and you don't want to spend your time estimating all those values. So this should hint at a simplification of the problem before you solve it. And how do you simplify values like this? You simplify them by rationalization of surds. Let me just write it down. Rationalization of surds. How do you simplify this? So simplify this by rationalizing, and you note that if you rationalize this by multiplying by just the value itself, you have a multiplication of, or a squaring of, there's going to be a squared term in the square root term in the middle. What I mean by that is if you have a root a plus root b, right? Root a plus root b, and you multiply that by another root a plus root b, what you're going to get is an a squared plus 2 root ab plus b squared. And you don't want this term here. You want to simplify such that you have simple terms to work with. And how do you get rid of this middle term? You multiply by the conjugate. So there's two techniques at play here. One, the rationalization of surds, which is, as you have learned, if you have something 1 over root a, this can be written as in this form, multiplying by root a over root a. This is equal to root a over root a squared is just a, so root a over a. That's the rationalization of surds. That's the first concept you want to think about. Second concept you want to think about is the concept of the conjugate. The conjugate is the same term but with a negative in the middle. And what that does is allow you to use a difference of two squares approach to this. So what we'll do then is try to look at what we get when we simplify each term, and this will the technique will then be applied or extrapolated throughout the whole expression. So we have 1 over root 1 plus root 2. If we multiply this by the conjugate and rationalize it by multiplying by the conjugate, we have my root 1 minus root 2 over root 1 minus root 2. And note, we're not changing the expression. By multiplying this by root 1 over root 2, it's multiplying this by 1, because what is this thing alone? This thing alone is just 1, and we're not multiplying anything by 1. Does not change the thing, still the same thing. So we're not changing this expression, we're just simplifying it. What does that give us? You'll note that here on top we'll just have this is equal to root 1 minus root 2, and then here you have a difference of squares. We know that a difference of squares is something of the form of, oh well, should have written this down as well. Concept number 3, that you have to difference of squares. That's concept number 3 that you want to look at. You note that, remember that a squared minus b squared can be written in the form a minus b, a plus b. Now we're doing that in reverse because we're multiplying these two terms here. And when you do that in reverse, let me not erase that so you can just quickly look at it as I go through this. Root 1, my root 1 looks funny. You can write this in this form. What does that give you? A squared, that will be root 1 squared. What's root 1 squared? It's just 1. Root minus b squared, what's that? Root 2 squared, that's just 2. So it's going to be 1 minus 2. That's what we have on the bottom. What does that simplify to? Simplifies to negative 1. Then you move on to the next term. We're not going to do this for all of the terms. We just want to see the trend, what happens as we simplify them, the trend, and then we can apply that trend to the rest of the expressions in the rest of the terms in the expression. So if 1 over root 2 plus root 3, multiply that by root 2 minus root 3 over root 2 minus root 3. What does that simplify to? A root 2 minus root 3 over, similarly here as well we apply the difference of squares, 2 minus 3. That simplifies to root 2 minus root 3 over negative 1. Okay, so now we see that there's this recurring trend. So we combine the two simplifications that we found. What do we get? We get root 1. Root 1 is just 1. We can just write that as 1 minus root 2 over negative 1. Then we add the following term, which is root 2 minus root 3 over negative 1. We simplify that. I'll just put dots for now. We simplify that, it becomes, by dividing by negative 1, we get negative 1 plus root 2 minus root 2 minus root 2 plus root 3. Oh, we see now what's happening. This root 2 is being cancelled by this negative root 2. This root 3 will be cancelled by the following negative root 3. Negative root 3. And so on. And similarly, the root 4 or 5, they will all be cancelled by the following addition. They will all be cancelled by the following addition. This only happens. This only happens because you have a root 2 here and a root 2 here, a root 3 here and a root 3 here, a root 4 here and another root 4 here. It only happens when you have that term occurring twice in the term, in the expression. However, the root 100 only occurs once. There's no other root 100 to cancel this root 100 here. So what does that tell us about how the expression will terminate or end? It tells us that at the end, this value, when we simplify 1 over root 99 plus root 100, we know where that simplifies to, because we have done the previous two, we know where that will simplify to 99 root 99 minus root 100 over negative 1, which is equal to root 99 plus root 100, negative root 99 plus root 100. And we know that this negative root 99 is cancelling that root 99 from the previous term. So the only term that we'll be left with is this root 100. So finally, at the end, because remember when we simplified, we got this here. We got that there. At the end, when it simplifies, we know this root 2 will go, this root 2 will go, the root 3 will go, the root 4 will go, root 5 will go. The only terms that are left at the end, this negative 1 right here, and this root plus root 100 at the end. What does give us? Negative 1 plus root 100 is 10. That is equal to 9. That's the solution. This one requires a bit of thinking, but it's not too difficult once you try and think through it.